this exercise, we're going to write a processor supplier and processor instance, in which the processor will contain all the stream processing logic. The first step is to create this processor supplier implementation. This returns a new processor instance each time get is called. The next step is to add a constructor, and you'll see where the store name variable comes into play soon. The get method implementation is important, that it returns a new processor instance each time it's called, declaring a variable for the processor context, declaring a variable for the key value store, and implementing the init method. This is called by Kafka Streams when the application is starting up. You'll want to store a reference to the processor context. Here, you're getting a reference to the state store by name and storing it in the variable declared earlier. Here, you're using the processor context to schedule a punctuation to fire every 30 seconds, based on stream time. Next, you'll implement the forward all method. First, you'll open an iterator for all records in the store. Note, it's very important to always close iterators when you're done with them. Its best practice is to use it within a try with resources block, so closing is automatic. Then you'll iterate over all the records. Inside the loop, you'll get a key value from the iterator. Next, you'll create a new record instance. Finally, you'll forward the record to any child nodes. Then you'll implement the process method on the processor interface. First, get the key from the record. Then use the key to see if there is a value in the state store. If it's null, initialize it to 0. Next, add the current price from the record to the total. Finally, place the new value in the store with the given key. We're not quite done with the processor supplier implementation, but we have some details to attend to first. Let's define the store name variable. You'll use it very soon. Next, you'll create a store builder. You'll need this for creating the state store. In the store builder, you're setting the store type to persistent and using the store name variable defined earlier for the name of the store. Next, you'll add surdays for the key and value types in the store. Kafka Streams stores everything as byte arrays in state stores. With store builder complete, now override the stores method on the processor interface, which gives the processor access to the store. Now let's build the topology for the streaming application. This will take a few more steps since it's the processor API versus the Streams DSL. First, you'll add a source node. Then you need to provide the name of the source node, followed by the key serializer, and then the value serializer. Finally, you'll add the input topic name to complete the source node. Next, let's add a processor to the topology. Again, you provide a name for the processor. Then you'll add the processor supplier instance you created before. To complete the processor node definition, you'll set the parent name or names for this processor. Note, there can be more than one parent name specified. Finally, let's complete the topology by adding a sync node. As we've done with the other node, you'll provide the name for the sync node. Next, you'll specify the name of the output topic. Then you'll add the key serializer and the value serializer as well. Finally, you'll add the parent name or names for the sync node. And congrats! You've just built a topology using the processor API. Now you'll instantiate the Kafka Streams object. Again, you'll add the utility method that will create topics and provide sample data. Finally, let's fire up the application. Note that the timestamps are simulated to provide more activity, and the observed behavior could be different in a production environment.